This is the last in a series of 4 recordings about computing history. Each lecture is about 15 minutes, so maybe an hour worth of material. And I've already talked about many of the devices and inventions listed here. Now, keep in mind when you're thinking of computing history that we categorize these devices as mechanical, the very earliest forerunners of the modern computer being devices that had gears and moving parts. Then we moved into electromechanical devices, devices that did use some electricity and also had moving parts. And from that we moved into the first generation of computers, such as the ABC and the ENIAC. And then finally we had the idea of the stored program computer. This idea, it was not created during Turing's lifetime, but he had the idea of a universal machine that would not require wire pulling and replugging and flipping switches every time you wanted to make a change to the calculation that was being performed or to the instructions that the computer was or the machine was executing. And so Turing had the idea of the universal machine that could perform many different tasks simply by switching programs or software products, programs, applications. And then von Neumann had the idea of the CPU, and that is the central processing unit that would perform arithmetic and logic operations. And those are two things that we have in our computer architecture today, the idea of programs and the idea of a CPU. And so we moved on into the EDVAC, the EDSAC, and the UNIVAC, with the EDVAC and the EDSAC using binary, again, something that is still used in computers today. Rather than having switches that you flipped on and off, you had a 0 and a 1, 0 for off and 1 for on. And then we moved into the UNIVAC. So these machines are getting faster. They can perform more computations. They are able to follow some basic instructions when you flip switches or give them punch cards. And then we moved into the second generation of computers, and they became smaller and even more powerful because of the invention of the transistor by Shockley, Bardeen, and Brattain of Bell Labs, for which they won the 1956 Nobel Prize in Physics. And then, of course, IBM is one of the leading companies developing computing technology and using the transistors and making the devices that are faster, but they're still large and compared to computers today, and they're still quite expensive. Then we also had, around the time of the second generation computer with the transistor, we also had the idea of magnetic tape. So instead of punch cards, which had to be kept in order and were loaded in through a hopper each time that you needed to access data or use a program, we're going with magnetic tape. We're going away from the punch cards. And so the tape would allow you to not only read instructions or data, but also to write instructions or data and to store that material. And you could access it much more quickly on a tape than you could on punch cards. And so from then we had the idea of high-level languages becoming necessary as these machines become more sophisticated. And so Admiral Grace Hopper, one of the more modern computer programmers who helped design the COBOL language, which was used for mainframes, Common Business-Oriented Language. And she worked for the Department of Defense in the 50s and 60s. And so then we move into third generation computer, and this is kind of where I left off. We have the invention of the integrated circuit, which is going to replace the transistor, and that is what brings in the third generation of computers. The second generation computers are characterized by using transistors. The third generation are characterized by using integrated circuits. So Jack Kilby and Robert Noyce are two men who were not working together. They were actually working independently, and they both came up with the idea of the integrated circuit in the 1960s, something we call the computer chip today. One integrated circuit could replace hundreds of transistors. So now we have tremendous speed. We can process information at a rate of millions of calculations a second instead of thousands. And we're getting smaller. So these integrated circuits, these chips conduct electricity along various pathways in the circuitry. And that's when we had, Silicon Valley. These integrated circuits use silicon wafers, and they have metal pins, and all of that works together. So they can be plugged into a circuit board, and they allow computing devices to get smaller and even faster. Now, in 1964, the IBM System 360 was one of the first computers to use integrated circuits, and it was so popular that IBM had a hard time keeping up with the demand. They were the main player in these machines at that time. And then the price starts to come down. So now they're smaller, they're faster, price is coming down, and universities, hospitals, and other organizations can now afford to use these machines as well. And now we move into the era of the mainframe. The mainframe is defined as a large computer system. It's usually for multiple users with multiple applications or programs on it. And the IBM 360 was in fact one of the first mainframes available. Now again, because of cost, these were used more by organizations like banks, government agencies, large corporations, universities. They were used a lot for payroll operations. Back when they first came out, they were used to keep records, such as at the bank, financial records. They were used by the Census Bureau. They were used by universities to store student information. So they were used for tasks that required lots of storage and processing huge amounts of information. And so you didn't have any graphical capability with the mainframe. It was a terminal that you sat at, didn't have its own hard drive. I mean, it was really just a terminal and a keyboard hooked into a mainframe that might be several stories up in the building that you're in its own computer room. And it was all text. There were no graphics, there were no help menus. You pretty much had to know how to navigate. You could tab from field to field. You had to know to enter certain commands to move around and things like that. So it's very, very basic compared to what we have today. And you could have hundreds of terminals attached to a single mainframe. So you had lots of people working on it at the same time. The mainframes are very fast. So you can have hundreds and hundreds and hundreds of users all doing very intensive stuff, and the mainframe it returns with a great response time. It's very quick. Whereas if you have a server and you have hundreds of people doing intensive calculations, running intensive software, it tends to bog down a little bit. But we're going away from mainframes today. There are a lot of federal government agencies still have them. The state agencies are getting away from them. They're so old, and it's hard to find people that know COBOL. It's hard to find people who have the skills to program on the mainframe, even though they're still very fast and can process large volumes of data very quickly, maybe even quicker than a server sometimes. So we're going away from that. They're not teaching COBOL anymore. You can't find people coming out of college that want to work on a mainframe. So we move from that into the fourth generation of computers, which are characterized by the microprocessor. And the microprocessor was actually invented by an engineer at Intel named Marcian Hoff in 1970. And the microprocessor is basically an entire CPU on a single chip. So you've got your arithmetic, your logic unit, all of the brains of the computer on a single chip. So before that, you had several larger components that made up the CPU. And now, again, we're going to get rid of several large components, go to one small component, and again, we're getting smaller in size and more powerful. So the small microprocessor made it possible to build a microcomputer that fit on a desktop instead of taking up a whole room. And the first of these was the Altair that was built in 1975. And then in 1976, you have Steve Jobs and Steve Wozniak designing and building the first Apple computer. Sorry about that. I'm getting choked up here. So we've gone from large devices to smaller devices. We've gone from thousands of instructions per second to millions per second. From very expensive to more inexpensive. So advances from the transistor to the integrated circuit to the microprocessor have allowed computers to become inexpensive, available to more people, and smaller and faster. And they're also more reliable than some of the older machines like the EDVAC and the UNIVAC. And so one statistic I saw said that for a point of comparison, if the cost of a sports car had dropped as quickly as that of a computer when we got to the microprocessor 4th generation era, a new Porsche today would cost about $1. So we've gone from these very expensive machines to extremely affordable machines today. Now microcomputers are what we call personal computers or PCs. They fit on a desktop. They have their own hard drive, their own storage capacity. You got the monitor, CD-ROM drive, we've got USB ports, keyboard, mouse, all that good stuff. So we have our input devices, keyboard, CD-ROM, USB for a flash drive. We don't have disk drives too much anymore. We've got memory, so we've got integrated circuits inside the computer, and that serves as our RAM. And we have our CPU, which is in there, that makes decision and does arithmetic. And of course we have the hard drive that we store information on. And we have our output devices, which include the monitor and printers. And some people do consider the hard drive an output device as well, since you write data to it. Alright, so that pretty much sums up the real highlights of computing history. And of course I've left out Bill Gates and Windows and how his graphical interface, along with the graphical interface that Apple had, really brought us into an era where anyone, not just a programmer, could sit down and use a computer and navigate around. It became a lot easier to use them when we went to these graphical user interfaces. So I will leave you with this. Remember, the test will be on Friday on computing history on the material that is in the 4 lectures. You may use notes, however, you must bring the notes with you ahead of time. You have to do them ahead of time so you can bring them with you to the test, because you will not be sitting at a computer and you do not have this material in your textbook. So take some notes on these lectures and good luck on the test Friday.